Hey everyone, hi, welcome you all to the office and welcome to Dev Day. Let me give you a brief introduction on what Dev Day is. So, Dev Day is a community event. It's an informal monthly event organized for the developers where developers come and share their experience and ideas and perspectives on different technologies that they are working on. So, we have done a lot of them in the past, and all of those are available on YouTube. So, I'll share the link in the end. So if you're someone who is working on something cool and you'd like to share it with the community, then this is the platform. And having said that, the talk for today is container security, understanding the security landscape by Vinayak Kadam. Vinayak has been working as a consultant for 9 years now, and he's been experienced with. He has been worked on domains like advertisement and automobiles and insurance, finance, etc. Which involves technologies like Java, Kafka, Kubernetes, and ESB tools, and he's also experienced with handling extensive amount of data in prod. So yeah, I'll hand it over to Vinay.
Uh, Thank you everyone for joining me. I think it was raining today evening, so I was wondering whether people will show up. Okay, so before we start, maybe we'll try to revisit some of the foundations that are required for today's talk, right? So system calls, right? So uh, I mean, there are two modes with like a user mode and a kernel mode. So the normal programs that are running, which are running in user space, don't have access to perform privileged actions. So that is where your kernel mode or system calls will come into picture. So there will be system calls that are there to for the user space application to do the privileged things. Privileged things like, let's say I want to bind to the port, let's say send data on the network. So all of these are like system calls. Then next is your file permissions. I think most of us are familiar with the file permissions, which let's say provides like a read, write, or a executable access. The first part, I think, which gives to a user, second part gives to the group, third gives to the other, right? Then next bit is like the UID bit, set UID. So that basically grants a, it's an initial version where the designer of the Linux system wanted to give access to the executable or permissions to the executable rather than a user. So once you set this bit, once this executable starts running, it will have the similar privileges as the owner of that file. So let's say owner is root, then it will have a root privileges to run. Okay. The third part is about Linux capabilities. Linux capability is like a more of a recent, you can say, recent development where all of these kernel space capabilities have a, or kernel space functionalities have a capability like capability sysadmin, capability chroot, capability kill. So that means you have a capability to do something. So your process should have that capability to do that action, right? Okay, let's try one of the example. Okay, so I'll be using Linux and Mac to do this example. So is my terminal visible to the back? Okay. It is not letting me go beyond. Okay, I'm assuming it is visible, right? Okay, so let's try to do the the exercise. So let's say I am having a set UID bit, which is, let's say I copy a CP command to as a my CP command, or I can copy a sleep command, right? So here what I'm trying to do is I'm trying to copy the sleep binary from the system, which is basically providing me the location of the binary. I don't have to find, it will be most probably in the /user/bin, but this command will basically give me that path, and I'm copying it to my local user. right? Again, you can see the my sleep is copied and it has a permissions like read at executable, whatever earlier permissions you had, the same permissions are there, and it is assigned on my particular user, right? Okay, so let's say I give or I own it by the root user to that file. So now you can see the file is now owned by the root user, and this group also has access, but it is mostly owned by the root user, right? And then let's say we give the chmod access. The the set UID bit that we talked about, which gives the privileges to run to be run as a owner of that file. So if we now see, you will see an additional bit, which is S. So this is the additional bit, like beyond the read write execute. This is a set UID bit S. So now if I let's say run this program without any sudo, I mean this will just sleep for like 100 seconds, right? So it is running in the background. And let's say I again go to another Lima console and I try to see what is happening. Okay, so here again you can see there are like two terminals opened on this on the Lima instance. One where I am running this ps command, and the other one where I'm running a sleep command. One difference you can see, the sleep command is now running with the root user privileges, right? So even though I haven't used any sudo command to run that sleep command, it is running with a user ID of 0. That means it is running as a root in this case. So it is a kind of a privilege escalation, where if you have a file which has a set UID bit set and the owner is root, then whenever you are running that file, it is running as a root in that ecosystem. So kind of a privilege escalation. Any question, comments? Yeah. S is for the set UID bit. The set UID bit is set basically. So S. Yeah. Okay. So
Like
okay.
when you said that it is used for UID, could you bit more specific? Like before, I have using Linux for some time, but I have never seen that S symbol. Then what do you, how it is different than read, write, execute? Or like when we give the root permission also, it always have the read, write, execute permission only. Then
Yeah.
what
Yeah.
do you
So
mean specific by S and UID?
yeah. Okay. So let's say I try to describe this slash user slash bin directory, right? So you can see there are multiple files which are running or has a like a read write and execute permissions, but there are also commands that are having that set UID bit set, right? So that means this command umount or unmount command can be run by a non-root user, and it will still work fine because this file is again owned by the root user and the set UID bit is set. Was that clear, or should I repeat?
No, I'm not got that clarity. Maybe I'm new to this, because from my engineering, I just run that Linux is having read, write, execute, and
Yes, most of the
yes,
time
I'm
you will
not
have read
getting
write
that
execute only.
perspective.
But this the S bit, right, the set UID bit is also there from the let's say early days of Linux, where it used to provide permissions to the files rather than to the users. But you can also see, right, it is highlighting me in a red form in my ID as well. So that means something is wrong here, right? I mean, it is trying to highlight me that, okay, something is danger, you shouldn't be doing this. So this was a practice that was there. It is still useful in few cases, but you shouldn't be doing it on a regular basis. Let's say in your own container, let's say you have a file with a set UID bit set, then you are basically asking for trouble.
Okay, okay, I will go to. Thank you. At
Yes,
least I
yes.
got some insight.
Yeah. Okay, so we'll try a similar exercise again with the ping command. So let's say we again do the same exercise, right? Like if I try to copy the ping as a my ping, right? So again, I will have a my ping in the directory. It is owned by the my user. not yet, the bit is the S bit is not yet set. So let's try to set that. Again, to perform this action, I need to do sudo. So in normal circumstances, I will not be able to do this action if I'm not a root user. So let's say my ping, sorry, this is root and my ping. And then again, I'll do the chmod plus s as well on the my ping. Right. So now this is used by or owned by the root, and as well as it has a set UID bit set, right? Okay. Can anyone tell me what or what kind of permissions the ping command will need, or what kind of system call it needs to make? What does the ping do?
Ping is used to check the connectivity of the system.
Right. So basically, it needs permissions or the ability to send packets over the network, right? So that means it
Yes.
needs to have that capability, then only it will be able to send it. Okay, let's try executing it, let's say for google.com, and then so basically it is started sending the data. And then again, let's try to analyze what is happening here, right? So again, the first command is the shell, the current shell, and the second command is where the myping command is running. But what is the difference that you see? You are seeing this running with the UID of my normal user, not of the root user. What you saw earlier is like a root user, right? And then even with the like a similar steps, the same ch owned by the root, and then ch mode by the or setting the set UID bit. Why the second process is not running as a root? Anyone? Okay, this is because the ping command is designed in such a way that it even though you are giving the root privileges as a ch or the set with the set UID bit, it is only taking the capability that it needs at the start, assigning this capability to itself, and only running as a normal user with those capabilities. So it doesn't need to be running as a root user all the time. So that is why you are seeing that difference. Okay. Okay. Let's go to the next one. All right. So what containers are made up of? So going to the containers, right? So how the containers are made up? So basically, it made up of namespace, the change root command, then the cgroups. So within namespace, you have UTS. UTS is nothing but Unix time sharing. In UTS, basically helps you set your host names. The name has not got nothing to do with the functionality here. Then second one is for the process IDs. Process ID is basically whatever you are running inside the container. If you run a PS and whatever running you're running on a host, you will see a different output of the PS, right? So that means there is a separation of the process IDs as well. Then mount points. The mount points are different on your host compared to a container. Network is also different. It connects differently. It has a different IP address. And the IPC is basically your messaging, the shared memory, the semaphores that it has in memory. So all of this namespacing basically means you are dividing or compartmentalizing the resources. Resources in this case are UTS, process IDs, the mount points, the networks, the IPC. So all of these are like compartmentalization of the resources. The second one is the change root command. Basically, you are changing the root location to something in the file system. Let's say something below in the file system. And then finally, C group. Basically, you are restricting the usage of the process, be it memory, be it CPU, be it IO. So basically, C group allows you to control the usage of those resources, right? So let's try to see one example where uh, we can try to run the process or run the Alpine container on our own, what it takes to run the container on our own, right? So for this, we'll need the Alpine image. So let's make a directory, let's say isolated or container. Okay. my container. Right. So first, I think we'll try to get the Alpine root FS, basically the Alpine OS, which has the things to run an Alpine Linux. So once we have that, let's try and extract that. So we have the Alpine Linux. So it has everything that it needs to run Alpine Linux locally. Okay. So first step is kind of done. You have the root FS ready. Second is the unshare command. So unshare is the command which allows you to like create those namespaces. So and you can check the man page of the unshare. It's basically talks about what all things that you can control while creating that process. So first flag you will notice that it is a fork, meaning we are asking it to create a separate process, not running the same process. Then the second thing is the PID. We are asking it to run in a separate PID namespace. And then third is the next one is the mount. We are asking it to create a separate mount for itself, the mount namespace names, IPC and the network. And once it creates this isolated process, we are asking it to run a shell command, right? Okay, so we are running that shell now. We are inside that shell. So if we, let's say, try PS socks, okay, you are able to see, I mean, almost all of the process that are there, right? I mean, it is running in the same directory, but it is able to see the whatever is still happening on the outside. So still some or a few things are missing. So let's try using the chroot command, right? The second part. So once we do the chroot, now if you do pwd, it will still point to the current root, right? So now the root has been changed to the current directory. So it can now see only the things that are below. It cannot see anything above, right? What are we missing now? Okay, so again, if we do psox, you are seeing like, okay, earlier at least I used to see things. Now I'm not able to see anything here, right? What happened? Anyone can guess? Okay, so basically the ps command, right? It reads from the /proc directory. So if you don't have a /proc directory mounted, it will not be able to read anything that is happening for the processes, right? So let's mount that directory. Once you mount this and then you do the ps, you'll be able to see all the processes that are running in this. Make sense? So far so good, right? But then let's try, let's say, talking to outside world. Okay, bummer, there is no network, right? So you have everything, but you don't have a network. You just have your local host, right? So then you will also need to create a network, right? So in Docker also, you will find that there will be a bridge, and on that bridge your container connects, and then it will be able to access whatever happening outside. So here, because we are creating the entire process by ourselves, so we have to also create that bridge here. So first, okay, let's set up that bridge. Yeah. Okay. Probably. Better. Okay. I mean, I'll copy the commands. Is the terminal visible there? Okay. So maybe I'll paste the commands in the terminal, and then I'll wait. If you have doubts with the commands, maybe stop me there. I explain more on the same command. Okay. So first command is basically trying to add a bridge called br1 of type bridge. So IP is again a command. So we are saying IP link add name called bridge and type as bridge. So this will create a bridge. So if I do IP address, so it will show me that there is a bridge. Currently it is down, but the bridge is there now. Okay. Second one is, okay, maybe I'll exit out of the presentation for now. Okay, second one is basically we are saying add address to the bridge, this subnet basically 192.168.1.4. So this subnet is basically getting added to the bridge. Okay. If we see the bridge again, you should be able to see the address has been added to the bridge that we created earlier. Okay. The next thing is the bridge. I mean, we are saying that, okay, bring up the bridge. Now it is set. Now try to bring it up. You'll see that it is still down because it has, I mean, we are not yet, the link is not yet active. So it will be still down for some time. Okay, then so bridge is there, but then the connecting pieces are missing. So next part basically adds the interfaces. So it adds the v Ethernet of type v Ethernet and peer as a v Ethernet. So it creates basically two v Ethernets, basically a single wire having two connections. And if you again do a IP address, it will show you that. Okay, I'm missing a D. So yeah, the bridge is there, the VETH2 is there, VETH1 is there. Okay. And then we are trying to bring up the VETH1 up and then assign that VETH1 to the bridge that we have on the host. So all of these commands are happening on a host machine. We are not doing anything on the isolated process that we have created. Okay. Then okay, next command is going to allow the IP forwarding, and then the IP table routes that allows the traffic to move from that particular host. So basically it allows a NAT routing. So anything that is, let's say, coming up with this subnet, it will allow that to flow through. Again, a forward rule for the same FR rule. And finally, okay, so the next command basically needs to grant that bridge or the VETH that we created, right? That access needs to be granted to the process that is running in an isolated manner. So it needs to have that access. So let's find out what is that. So the command that we shared, right? The unshare command. So unshare command is run here. So it is again executing that, and this is the one that is executing that unshare command. So yes. So in this, we have to provide the process ID to which we are granting the permissions. So we are saying that this VETH2 is allowed to be used by that 8696 process, which is the unshare process that is running in the another terminal. Right. So yeah, now I think we are all done on the host or the bridge setup is kind of done. We created one the connection. One is attached to the bridge, and the second one is allowed to be used by the process which is running in the isolated process. So let's go inside the isolated process and try to again here we are adding that process. So because we allowed it, that's why it was able to access it. If we didn't provide that permission, it will not be able to use it in this process. Okay, so next part is then we say IP address up. Okay, so the link is kind of up on the isolated process at least. I can see it is, so this is VETH2, right, which is attached to the isolated process, and it is up. Let's go and check on the host as well, whether the bridge is up. So we can see BR1, this is also up now, right? So bridge is also up, and the process is also able to access that bridge. Let's try pinging, right? So it is able to ping as well. So it is able to reach to that bridge now. And the next action is basically like we have to add a default route, which will like all of the traffic should flow through that bridge now, because this process doesn't have any other network access. And then we are adding a name server resolve config in that container, so that it will be able to resolve the name using the 8.8.8, which is a global DNS config, right? So once everything is there, now I think we should be able to use the network, right? So now it is, earlier now it was not able to use any network. Now at least it is able to use a network going through the bridge which is attached on the host, and it is reaching out to the network. Tedious, right? The setting up the container yourself or the isolated process yourself. Yeah, even I felt so. But yeah, I mean, even though it is possible to do this on your own, you are also missing a lot on other things that are there. So what are we missing on? I think first thing is the ease of configuration, right? It was difficult to do it. You have to remember a lot of things. You have to do it all the time, every single time manually, right? Uh, and then, I mean, simple network setup took this much time. Imagine something complex like, let's say, mounting a volume from, let's say, EBS system, right? This will involve like a lot of steps, and everything has to be done in a correct order. Even if you miss like a single step, everything will be misconfigured basically. So I mean, the container runtimes provide that ease of configuration to you. Then the layered file system. Okay, so in this isolated process, right? Let's say we are creating something. Uh, I mean, and even if we like, let's say, come back later, this something that we created still remains there. So it's like it's not isolated, right? So I mean, whatever we are doing, it is persisted then and there. So the advantage of real containers are not there, right? Uh, and then the versioning and caching is what we are missing on. Let's say whatever steps that you are doing, let's say in a Docker file or a container file, you'll be able to see an instance cache happening, right? So let's say the step is not changing in the next time, so it will be able to reuse that thing, right? So it will not recompute whatever we used earlier. So versioning caching is missing, completely missing. And then okay, ephemeral storage we talked about. Then it is also not very secure. Secure meaning we have done it manually, but then it could also be able to, let's say, escape from that isolated process and come onto the host, right? So there are no security measures that are happening there. So those are the things that
Could I
are.
ask one question?
Yes, Indrajit.
Like this is related with Kubernetes. Please ignore my question is wrong put it. If you say Kubernetes has got that versioning system, when you say that versioning system, it is related with the Unix or it is Unix with Kubernetes?
Uh, okay, I'm versioning. I'm talking about the Docker layers or the container layers that are there, right? So every time you're, let's say, adding something to your container, right? So it will get versioned then and there. So let's say even if you're adding a simple file, that will get versioned in a sense. So here, if you're, let's say, doing something in the process, it will not get versioned, right? So we have.
Okay, got it. Yeah,
Yeah,
thank you.
yeah. Okay, then the question, right? What made the containers popular? I think the standard or the main problem that it solved is the isolation, right? It provided a isolation from different processes that are running. So you will be able to run with, let's say, X version on one container and Y version with another container. So you no longer have that same dependency problem that needs to be across, let's say, on the entire operating system. You can run your own things without, let's say, getting affected by some other thing, right? Then the repeatability, basically, you are able to do the same thing again and again. It's not just that, okay, I did once, it worked, and next time onwards when I try, it doesn't work. It's not like that, right? So those steps are repeatable. That is why, like, people also, okay, so there's no longer a problem of it runs on my machine. Once it runs everywhere, right? Uh, sure. Let's go further. Then the next question is, are containers really secure? So on the left side, you have the virtual machine where the infrastructure is there. There is a hypervisor which is facilitating the guest OSs to function. The guest OSs have different binary libraries and then their own applications. But if you compare on the container side, you have infrastructure, you have operating system, and then immediately there is a container engine. And all the containers that are running, they are running with their own binary libraries and the application files. So one major difference that I see is the host operating system, right? It's kind of shared between all the containers. So if you compare the security of a container to a virtual machine, it is very less secure. So if, let's say, the container escape happens, let's say in container A, the application A, the whatever escape that happened, it will be also able to access and control application B and application C. right? So, but that is not the same case with the VM. So even if let's say something happens on the first machine, the app A, they'll not be able to go beyond, let's say, that application A machine. That will be remain in there only, right? So it is compared to a VM very slightly less secure. Some kind of isolation is there, but again, that isolation is, I mean, if you misconfigure it, it is very easy to break. So that is where I think you need to be very like sure and then apply the configurations in a judicious manner so that you don't misconfigure it and then open to the vulnerabilities. Okay. Uh, Next one. Okay, these are the security principles that are referred or applied in the container security. So first one is like a least privilege. Give the privileges that are required, only the privileges that are required. A defense in depth. You have defense in multiple layers. So even if like one fails, you'll be able to, let's say, limit the vulnerability or the exposure to that section itself. And if you because you have multiple layers of defense, if one fails, the other one will be able to save you. Then reducing the attack surface. Basically, if you have too many things that are running or a complex system is there, then you are opening yourself to a larger attack ecosystem. Okay, then limiting the blast radius, again, defense in depth and limiting blast radius goes hand in hand. So basically, if you have defense in depth, you have layered defense, then whatever happens will be limited to, let's say, in this case, right, the virtual machine was able to limit the exposure only to that machine. Likewise. And then the segregation of duties, basically, all the applications should have their own set of duties or smaller set of duties so that they are doing just what they need to do, nothing else. Right? We'll be referring to these principles again and again when as we go further. Right. So the typical container life cycle, right? So you have a Docker file, container file. You build that, you write that Docker file, container file, and then using that you build a container image. That container image gets pushed to the registry, and from that registry, you use it in your let's say daily workloads. You're running production workloads or running something locally. So that's the typical life cycle, right? We will see what can happen in these steps. What are the types of attack vectors that can happen, and how to defend or how we can defend against them. So this is one of the attack vectors. It's not. It will not. I mean, these are not just the limited set. It can be beyond this as well. So you can see that on the left side you have a source code. And you publish it to a code repo that goes to the CI build from that registry and deployment. So but in between this cycle, you can see that the source code can also get tampered. Someone can tamper with the Docker file as well. The base image that you're using could be vulnerable. The vulnerable dependencies, the library that you're using could be having a vulnerability. Then someone could attack your CI build itself. Let's say whatever you're building, they are replacing it with something else in the CI build itself. And then let's say if you push something to registry, and after that, let's say someone has access to that registry, then your image can also get tampered. And finally, during the deployment, right, if your registry is not secure, someone can intercept your traffic and change the content of the image midway. That can also happen. I mean, there are many more things that can go wrong beyond this as well. But I mean, this is one of the attack vector. Let's see. I mean, if you have any questions, okay, if there are no questions, then we can go further. Okay, first, let's see. I mean, how to, I mean, while authoring the Docker file or container file, what things that we should look for or what things that we should take care of. So first thing is tag versus digest. So everyone knows what a tag is, right? So the first line that goes in a Docker file is a from line. We provide the name of the image and then the tag, right? This tag is nothing but it's supposed, I mean, it is supposed to be like a user-friendly version that everyone can read. But this tag, I mean, let's say you are referring to, let's say, I mean, referring to a latest tag is always a bad idea. You should be using a specific version rather than a latest version, because latest will always change. See, the tag can change, right? So, I mean, that also means that whatever versioned image that you're using, that can also change if someone publishes new under the same tag, right? If that happens, what happens? Your repeatability goes for a toss. So what you can do here, you can use the digest. Digest is nothing but the hash of all the layers. So if nothing is changed in that layer, hash will remain same. So you can be sure that, okay, whatever image I referred earlier, I'll get the same image every single time. That means you get the repeatability. Okay. Second is smaller images. So let's say if you are using a Ubuntu based image that will have many more files or things that you're not going to use that frequently, right? It will have many more utilities, many more commands that you'll not be using while you're running your application. So in that case, a smaller images like Alpine image will be helpful to you because it will have only things that are bare minimum needed. And we have also observed that whenever you are giving your images to scanning to the, let's say, security teams, you will get result faster if you have a Alpine image, because it has nothing that can get that will be vulnerable, right? Then I think the third option is even beyond this, which is distoless. Distoless is basically, it takes a concept of only copy what is required to run. If it is your, let's say, if you're running a JVM application, just the JVM and the jar that you need to run, nothing else apart from that. But I mean, this will work, let's say, for applications like Go or Rust, where you have a typical binary built. I mean, binary has everything that it needs, right? Everything like shared dependency and everything. But sometimes even your Java applications or applications can depend on the shared libraries, let's say for let's say ZSTD or LZ4. So they are depending on the libc share SO files, the shared object files. And if those files are not there, then your application might not function as it's supposed to. Then okay, so then you should be using the images from the trusted sources. I mean, typically who are scanning frequently, and whenever the, let's say, new vulnerability gets updated, it gets fixed in that image. So one source is, I think, Wolfie ChainGuard, so you can use images from there. It's a paid or a subscription based service, but you'll get a trusted image from there. You'll find lesser and lesser vulnerabilities in there. And then the next kind of image is basically unprivileged images. Everyone might have used Nginx, right? So Nginx basically runs on port number 80, right? And anything, let's say, runs lesser than 1024, you should have a permission or privileges to run on port number 80. So every time you're running a Nginx image, basically it is requiring a root to be there. But then, yeah, this is a problem. And then people have talked about it, and there are now unprivileged images. Let's say from the same vendor, Nginx provides an unprivileged image which is running on a 8080 port, so that you don't have to run with a root on your system. And second set, okay, I mean, next is the non-root user. Again, talking on the same line, most of the time, whenever you get an image from the Docker Hub or any registry, right, public registry queue, you will get that image which is running as a root itself. So you should be using a user command to restrict that application to a particular user called, let's say, app. Next is multi-stage builds. So many times whenever you are building your Docker container, right? So you might be, let's say, first compiling your applications and then adding, let's say, things on top of it. And then finally, let's say the artifact gets built and then you publish that. But in this case, when you build that Docker file, you will have like a lot of unnecessary tools built up in the chain. Let's say you don't need a Java JDK, right? You just need a JRE. In case of, let's say, Node, you might be installing the Node to build the Node application. So it might have like a lot of third-party dependencies downloaded right there in the container. And when you build that container at the end, you will have everything in that container. You don't want that, right? So that is why, I mean, it is suggested, or it's good to use the multi-stage build, where one stage has built something. You can just use the artifact from that stage, and the next stage can start like a fresh from the fresh container. So uh, I don't have one, but I mean, we'll go with one. Yeah. So the next is basically immutable containers. So your container should have everything that it needs. We don't need to like add things on top of, let's say we are running something at the start, let's say downloading something, let's say if some font is required, so it will download that font and then maybe start using it, right? That means the container is not self-sufficient. It has to get something at the start, and then if you're using, let's say, particular software or some dependency, then every time you are doing that install on the fly, we'll have a different version. uh, that means again your container build will be not the same. Your container, I mean, if you're running that image multiple places, then it will not be the same version every place. And again, the set UID bit, right? The set UID bit that we talked earlier. So you should try and avoid it as many. I mean, because it is dangerous. Once it have a set UID bit set binary, it can do anything on that container. So you should avoid that. Avoiding secrets in the Docker file. I mean, we think that if the final container file doesn't contain any secret, that means the secret is not there. But that's not the case. You can still see the secrets. And the run commands, right? They are slightly dangerous, so you should be watching what you're adding in your run commands. Uh, the the attackers who are targeting the Docker files, right, can run or replace the binary that you're referring to. So try as much to avoid the run commands in your containers. Okay, let's maybe take a demo. Maybe yeah, so this is the Docker file. I mean, demo application is a simple Spring Boot application, which has nothing but like simple main application, which is if you start, it will run it. Uh, yeah, this is visible, right? Yeah, so once you start it, it will run it. And let's look at the Docker file that we have. So the first line from the Docker file, it is using a Eclipse Tamarind 17K JDK, right? Anyone, what is wrong? I mean, not wrong, but I mean, okay, so build the application, we will need a JDK. So it is using a JDK. Then it is setting a work directory, copying the required files, running the Gradle W to build the application. It is also copying a secret, a dummy secret to build the actual application. And as a user, I feel that, okay, the secret won't be there in the final build, because when I run the final application, because I have removed it just before the build completes, right? I think that the secret won't be there as a, I mean, this is a file where I'm showing that this is what you shouldn't be doing. You should avoid this, let's say, setting secrets in your Docker file. So yeah, I mean, if I were be using this as a multi-stage build, right? So then I would have created this. I would have run everything, and then just before I run, right, then I would have, let's say, created a, let's say, JRE image, use the JRE image because I need just the JRE, and I would have copied the jar from the previous stage. Let's say the build that I mean, the whatever Gradle is building, right? So it will create a jar artifacts. So I'll maybe just copy the jar artifacts from the previous layer. So you can see it will just have the plain Tamarind image, and from that next onwards, only the required jars to run here. So you can also tell from which stage you have to copy, right? And even this ID is also telling you that this is a separate or a different stage itself. Okay. Yeah. And again, we can also add a user command here, and we can tell that, okay, this should be used from a particular user, so that we are not. So it is started with a particular user only, right? Okay. I'm going forward. Okay, next stage, once you have the Docker file ready, you will try to build it, right? So while building, we should be caring about, okay, so you most of the times we'll be, let's say, using Docker, which requires a daemon build. That means there has to be a Docker server running, and then a Docker CLI or Docker client can tell to the Docker server that, okay, I need to build this image, and then only it can build it. So basically, it is a daemon-based client server protocol. This is slightly problematic because most the Docker that is running, right, it will require a root privileges to run most of the time. So long-running daemon processes are kind of not necessary. So there are alternatives like Podman. You can run the or build the image without even needing to run an actual server. So your Podman CLI can build the image from a Docker file without even need to run any Podman server. Then you have to secure the build environment that manages. So if your build environment also has like many things on it, again it gives the attack surface, right? So because it has multiple binaries, multiple things, people can try to exploit, let's say, particular binary that has exploit available already. So there are things like thin OS. You can reduce the uh, things that are required to run on that particular the build server that you're running, CI server or build server that you're running. And then you can also scan regularly for known vulnerabilities using the tools like Gripe, Trivy, and Clear. Uh, so scanning will help you till a point. Uh, let's say you're scanning today, right? Because today that vulnerability was not there. It was not. It will not show in the report. But let's say 6 months down the line, with the same image, there could be a vulnerability because the vulnerability might have get discovered in between. So you have to scan it regularly. So these tools help you scan it, let's say in the CI on your local while you're building, but there should be also scanning done on the registry. Let's say your image is stored in registry. The registry also should scan the images on a regular interval to detect any vulnerabilities or known vulnerabilities that are that are there. Then next is basically registry, right? Registry is like most important because you're building everything and pushing it there. If it is a public registry, that means it is, let's say, managed by someone else, right? And then if you are hosting your images there, there's a good chance that, let's say, something goes wrong, that image might get compromised. So it is good to, let's say, host your own private registry, possibly within the VPC where you'll be actually running some of your workloads, so that it is closer, it is in a closed environment, as well as it is the access is also limited to the people, let's say, who are supposed to having the access. So the access control is also required on the registry. Then you can also go a bit step further and do the image signing. You can use tools like Notation, Intoto. You can generate or sign the images using your own private keys, and then verify them just before you run with your public keys. We'll see one demo for the Gripe and Trivy, the tools that scan for the vulnerabilities.
Could
Uh,
you tell something about thin operating system? Like it is how does it different from the operating system?
I mean, thin OS is kind of a concept, so it's not actually a distribution, but there are thin OSs out there supported by major OSs like Fedora, uh, CentOS. So they support the thin OSs. Nirji.
I just to understand that, just see, like if you take the virtual machine, you got that hypervisor or container, you got a container which act as an operating system only. Then thin operating system sit in which layer, like or which part of that operating system, before the Kubernetes, before the Dockers, or after the operating system, or if thin operating system is there, how it is going to be different than the future's operating system?
Okay, okay, this point is specifically for your build environment. So you'll be building somewhere, right? Using, let's say, some Jenkins server or let's say some GitHub action. So there you'll be having a image or a server running as a build environment, right? So there you can use a thin OS. I mean, I'm assuming that it is a virtual machine, but if you are running, let's say, the same on a container, let's say Jenkins on a container, then it doesn't apply. So there also you can use, let's say, Alpine like containers for Jenkins and let's say GitHub Actions.
Okay, thank you.
Yeah. Okay. Uh, okay. So first, let's say we scan with Trivy. Trivy is again as I mentioned, it's a CLI tool. So the image, the Docker file that I showed earlier, right? It basically, I have built that image and I called it as, let's say, my image, and it is hosted on my local Podman machine. Okay, so okay, the result was kind of already done. So it will print this result in a table-like format. And because the application that I'm using is let's say slightly older, and because of that, there are a lot of vulnerabilities that are mentioned. One, I mean, vulnerabilities, let's say, related to the Tomcat embedded core, and let's say it is pointing to the CV that is linked to that issue. CV is like common vulnerability and exposure. So let's say some issue gets discovered in your application or software, right? It gets disclosed as a CVE, and each CVE gets a number. Like first part is basically the year in which they are disclosed, and second part is the number assigned to that CVE. So there is again an agency which assigns these numbers to the CVEs. Yeah, and maybe some of these CVEs like maybe applied by the vendor or the distributions, right? So there can be a distribution specific advisory as well. So I mean, sometimes these CVs also generate false positives. That means this vulnerability might not be applicable to you because it is applicable under very some circumstances, which let's say might not happen to you in your environment. Right, not right away, but maybe in future. But currently, let's say it's not applicable in that distribution also. So this report also you need to take it with a pinch of salt, and you have to maybe evaluate what are those vulnerabilities and understand whether it is actually causing issues, and then only fix it. Uh, okay, maybe I'll try to minimize this. So each vulnerability, okay, also gets like a severity. Again, this is assigned by depending on how severe it is, medium, high, critical. Uh, Again, it depends on your organization where you want to like run with like zero vulnerability, zero known vulnerabilities. This is only for known, right? If there is something unknown which is already happening, if it is not yet discovered, there is no way for you to know about it, even with these kinds of scanning. Right. Okay, I think I missed one part earlier. I think the Podman, I mean, we talked about having the secrets in your application, right? So let's say if the secret is not there finally in your container, but even if, let's say, someone tries to inspect your container, right? They can still see what that secret was. And let's say Podman basically tracks what command was run and what was the hash it created. So it is possible, and people can go back and look up what you have done in your image. Uh, there's also a tool called Dive that I just got to know sometime before. So this tool also helps you visualize and understand at what step and what happened. So first step is where the image is built, everything is added there. Next step, let's say what changed in this command, only etc has changed. So it is a pretty good tool to visualize what happened with your like Docker file. Each of the steps, what they changed, where it got changed, everything can be tracked. It also shows how much is the image size and what stage added what size of the content. Let's say total size is 800 MB, but how much of it got added? Let's say it was there from start only, right? Okay. Yeah. Yeah. Right. The gripe command one, but it is basically trivy and the image and the name of the image. Okay, the question was the command that I tried for image scanning, right? They wanted to like repeat the command. So for gripe also, like you can specify gripe and the name of the image. This is also again will download the vulnerability DB and try to analyze it against the image that is there. It will take slightly longer. Uh, Maybe the version that I updated is taking slightly longer, but it will also provide a similar report that you saw for the Trivi, where it will list out all the known vulnerabilities. okay, how it does, basically it will first scan based on your packages that are installed by your operating system. First level, right? If the operating system says that, okay, this package is installed, it can basically scan, let's say, whether this version has a vulnerability, known vulnerability or not. And that is how it will report it here. And again, the second level is basically based on the files that you have installed. The installed file will also have some version against it. So it will try to see in the vulnerability database whether there is any known vulnerability that is there in the vulnerability database. Okay, this was the command. I mean, it will take slightly longer in this case. Yeah. Okay, in the interest of time, I'll go forward. So we saw the things that we should take care of while building the images. The next is while running the container itself. So like all you're done, right? Like you have made sure that your Docker is good. You have made sure that your image building process is foolproof. The next part comes in here is your admission control. But if your deployment environment is not checking for scanned images, someone can skip all of that and just deploy the vulnerable code there. And we know that, right? Even if one container or one container gets gets attacked or gets scrutinized, or I mean, if it gets compromised, then all of the other containers are also compromised on that host and then on the cluster as well. So all it just takes like one bad container on your system. So that is where the admission control comes in. Admission control is based on Kubernetes admission control, the webhook. There are two types of webhooks. One is like a mutating webhook and the other one is a validating webhook. So in this case, the validating webhook will make sure that you have a scanned image and then only you go ahead and deploy. So there is a tool called Gatekeeper. Earlier it used to called as an open policy agent. So this allows you to configure your policy as a YAML, and you can say, make sure that, okay, so whatever image that I'm trying to pull, you can say, make sure this is scanned, then only go ahead and deploy. So that way, no one will be able to skip all of the steps that you've done earlier. Again, this will slow down a process a bit. But yeah, I mean, it will make sure you have a scanned images or scanned workload deployed in your cluster. Second point is about volume mounts. So because your containers will need to store data, read data, so it will need to mount those volumes. So and we need to avoid mounting on the critical paths like /etc. /etc is where like your password files or the credentials are stored. So if the container gets access to that, it can write and modify the contents in that file. /bin is where your binaries are stored. So if it gets access to that, it can override the existing binaries and provide a superficial or compromised binaries. Varlog, again, every container that is running in the cluster by default has access to the varlog by a symlink, but it is only writing some logs, but it is only a point where it can change that symlink to some other place, right? So it is just waiting to be exposed, kind of a thing. So we should avoid mounting on those paths. Next point is about sandboxing. So sandboxing tools like seccomp. Seccomp is basically secure computing. It allows you to sandbox your application, basically sandbox and analyze what permissions are needed or what system calls your application needs. Once you have that information, then basically you can apply the seccomp profiles so that your application can only do those system calls. Then also there is a seccomp BPF, which is again a Berkeley packet filter. This initially came up for the analyzing of the or routing of the packets directly from the kernel code. But again, it lets you enhance or have. I mean, basically, it is building a visibility into the system calls and the various kernel functionalities. AppArmor is also on the similar line. It is basically you can create profiles, attach them to your containers, and then you can use them to restrict the usage of your container applications. SE Linux, again, it's a very old concept where SE Linux is to restrict the files to a particular process so that any other process executing don't have access to other processes. And then, okay, so Tracy can also help you see what are the system calls that are needed. I have one such a thing running already. So this Tracy container is already running on my system, and it is like capturing all the system calls that are being made. So it will basically, it is kind of audit log where you want to see, let's say if you're trying something new, and then you want to see what is it really secure or not. So you can also enable this kind of tracing, and then you can see what are the system calls that is make. It is kind of a sandbox, right? There you are trying to see whether this is actually useful to you or not, or if whether it is harmful, has a malicious content. So yeah, tracing will help you there. Yeah, so let's, I mean, the next demoable part is regarding the seccomps. So the seccomps, right? Seccomps, as I said, you can also run it in audit mode. So SCMP act log. So just it will just log it. So it will not take any action. It will just log it. Second one is a blocking. So in the action, it is saying that it will allow only these system calls that are listed here. So that means if any of the other system calls that are needed for your container, it will not be able to run, or let's say any other attacker is trying to run something. If it is not there in this list, it will not be able to run it. Right. Okay. Let's see one example. Let's say the bind, right? Bind system call. It is required by the process. So let's say we remove it and then add it to the. So this. Okay. So this is. Yeah. So the first one is. I mean, this is a. This will error out if your application tries to use any of the above system calls, it will error out, right? So let's try and run the application. Right. Okay. So with Podman, right, you have to provide a security opt, uh, which will have a seccomp as the file that you want to use. So in this case, the file that I have in that ID, open in the ID, right? The same file I'm providing, and the image is basically the image that I'm using, which will run just the Spring Boot application on port 8080. So you see, the operation was not permitted and it failed because the bind system call was there in the disallow list. Let's say we move this call to the allow list. Okay, yeah, so this is the allow list. So let's add the call here. And then let's try to run the application again with the same prompt. Now the application is able to run because we provided that system call permission or allow permission there. So this way, basically, if you know your workload, let's say your workload is just APIs, then you can create a seccomp profile for your containers and then apply that profile to the containers. And I mean, any other permissions apart from that workload, your container doesn't need it. So that way, anyway, if the anyone tries to access or try to use it, they'll not be able to use it. Again, as your application evolves, the list of permissions that you need to give will also evolve. So you need to keep adding it up, or you have to keep it up to date. Okay. Okay, least privileges. So you should be giving the permissions that are needed for your container, least possible privileges to your container. You should have like RBAC on your clusters to make sure only the authorized user or the user has privileges, right? Should be able to do actions. Next part is the network. Because you are running a container, the network is also quite open. Any container can talk to any container. So there also you need to have like a network policy, and then or a service mesh basically, which is opening a MTLS connection and then making sure only the containers that are supposed to talk to each other will talk to each other. So that way you can make sure that the network is also not compromised in the sense. Okay, next is the important bit, right? Passing secrets. So every application, let's say at some point needs to connect to some place, and that will require, let's say, authentication or credentials. That way, that place you will be, you need to pass the secrets. But again, environment variables, the files and the Kubernetes secrets, it is scratched out. That means you shouldn't be relying on them to pass the secrets because environment and files, any root user on the system will be able to open or see the environment variable and open the secrets file that you're creating. So that way, it is very less secure. And the Kubernetes secret that we create without RBAC, it is just a base 64 encoded string. So if you are not using RBAC in your cluster, then it is very easy to open the secrets there. So you should be using something like HashiCorp Vault or AWS Secrets Manager, which can inject the secrets in your application at runtime. So they are not in your Docker file, they are not in your environment, they are coming directly to your application at runtime, right? And then finally, the alerting and action bit. So all of this is there. Uh, if so, you should be having profiles for your applications, like a network profile. What are the things that it accesses on a usual basis? Executable profile, what it runs as an executable file. File access, what files does it access? User IDs, which of the user IDs actually are logging and using things. So these are like profiles. If you build them up over time, uh, tools like Falco and Tetragon will be able to stop, let's say, anomalous behavior. So let's say someone has injected a crypto mining malware into your container, right? And if you are running Falco there, so it can detect, let's say, based on your executable profile, you can detect that, okay, so this is not the executable that usually runs. It can stop it and maybe kill the application. But again, if it directly kills the application, all of the logs and everything will be lost also. So you have to think what is the best mechanism to prevent this execution, at the same time not losing the evidence as well, right? So Falco and Tetragon tools can help you in those aspects. Okay, next part is about the container escape vulnerabilities that have happened in the past. Again, you can see some of the CVEs which are, let's say, in 2018, 2019, and then some of them very recent as well. The first one, basically, the run C vulnerability, wherein someone replaced the shebang line, right? They replaced that with the run C binary itself. So there, it was able to like break out of that because it was running with the run C the file. It had a privilege against setuid bit set, right? It was able to run it as a root and maybe break out of the containered environment. Then the second one was so because the name, we can also give the namespace sysadmin rules, and because of the vulnerability in the kernel itself, it was able to break out of the kernel the breakout of the container. The third one is again based on a file descriptor leak. So file descriptor was there dangling, and then it can point to any other file system on the host, and then it can break out or try to break out of the container from there. Fourth one is again a race condition between Docker and a build kit, where they were trying to update the cache, and because of the race condition, the cache was again dangling, and then allowing again going to the root. I think fifth one is again it used to allow to delete the mounted files, arbitrary files from the mounted system. The last one is on the build kit bug that allows breakout during the image building itself. So these are like maybe not happening in all the environment or possible in all the environment, but these are like still the vulnerabilities that are still happening today as well. So some people refer to it as like a leaky vessels. They are bound to be leaky because no matter what you fix it, because of the architecture, it is going to be like that only. The architecture, I mean the common components that are there. So always there is a possibility, there is some bug out there which is there in the container engine that will try to break out and then try to gain access to your host. So, so, yeah, I think that was it. Any questions?
It's about secrets. We've discussed prevention measures like ensuring that the attack doesn't happen or just stopping it before it happens. So whenever we try to put a secret, whenever we by unintentionally put a secret in GitHub, any of our VCS, we try to rewrite the history by Git rebase. Do we have a similar mechanism for Docker as well?
Okay, I mean, so the question was whether there is a mechanism to deal with the, let's say, accidental secret disclosure. Let's say if you disclose some secret accidentally in your Docker file and you build the image and push it. So the simple answer is because this image is hosted somewhere in a private registry, right? Basically, simply you can go and delete the image itself. And the second measure, that best measure that you should take is basically rotate the credentials. So whatever secret was disclosed, we can basically rotate the secret so that it is no longer like accessible anymore. Okay. Uh, any other questions on the call? Cool. These are some of the references that I used to prepare this talk. Okay, yeah, go on.
For a specific state. And one of the client's demands is that he wants that on its premises, on his subdomain. The way I can do it with using Docker. But मुझे क्या करना है कि जो कोड है जो एग्जैक्टली फुल स्टैक एप्लीकेशन का कोड वो उसे एक्सेसिबल नहीं चाहिए राइट
Okay.
डॉकर में एक काम कर सकता है कि कॉपी कमांड डाल के वो कोड पूरा कॉपी कर सकता है अंडर कंटेनर से जाके वो कैसे कर सकते हैं कि उसे एक्सेस नहीं रहेगा किसी भी कोड
Okay, so the question is basically how you move the some parts of your code that you want to run on your client premises. I mean, yes, you can copy the codes that, let's say, you will be running, let's say, for that specific client. I guess you can copy it, but once you give that image to your client, I guess your client will also have that access to the code. So
like a time or let's say
yeah.
what we can say the authentication type of mechanism for the content.
I mean, unless you host it as a service, I mean, if you're giving away your container, right? That means the access would be there. Anyone can open your container and see the binary files, even let's say decompile or decode the files that are there.
There is anything.
I mean, once you disclose it, it is disclosed. So, cool, folks. Thank you for joining us today. So these are our meetup and Discord links. Do join on this. You can simply scan it. There will be future events that will be keep on doing it. Do join us here for that.